Hi, I'm Michel Dufresne. I'm an independent consultant in the New York City area, specializing in rule-based business application. This is part two of a three-part series on how we can use the semantic web technologies for specifying the domain model of rule-based business application. In the first part, we looked at the web ontology language, which is a W3C standard, and in particular, we looked at the LDL, which stands for description logic. Description logic is based on a formal logic-based semantic, and we look in the case of OWL at the 6 class descriptor that are available for building complex class as expression of other classes. For example, we looked at the definition of the impressionism art collector being defined as the intersection between art collector and all of the individual that has at least one artifact of type impressionist painting. And in turn, impressionist painting class is defined as the intersection of late 19th century French painting style class and the artifacts with paint stroke of unmixed color. Now, if we look at it from a visual diagram, we see that the impressionist art collector being defined as the conjunctions of those two class descriptor, that impressionist art collector must be a subclass of art collector, which means that every impressionist art collector must be as well a art collector. Since art collector as their artifact of being of type artifact, then it follows that the impressionist painting must also be of type artifact in order to comply to that axiom. And also, impressionist painting was defined as a conjunction of two classes. The late 19th century painting style class and artifact with paint stroke of unmixed color. It logically follows that impressionist painting class must be a subclass of all those three classes in order for all of the axioms to be true at the same time. So we see that when we express classes with class expression that has very clear semantic meaning, we can deduce the type hierarchy or the class subclass relationship of the domain model in order to have the class axioms to remain valid based on description logic. Now, to write rules on top of those classes, we need to see the distinction really between a description logic formalism and a logic programs formalism. In description logic, it complies to the open world semantic, which means that it does not assume that the information is complete in the knowledge base. So it is said to be a monotonic formalism, which means that as you add more information to the knowledge base, it will not invalidate the logical deductions that were obtained previously. While logic programs, it complies to the closed world semantic, which is a well-known semantic used in relational databases, where it assumes the information to be complete. So the lack of information is essentially a negation. And for that, logic programs are said to be non-monotonic, because if you add new information to your knowledge base, then it may invalidate some deductions that were taken previously. So there is a mapping between the description logic entailments and the logic programs constructs. This mapping is actually well described in this paper here. Now, what it really means, open world versus the closed world semantic, what's the real distinction between the two? Well, essentially, it comes down to how negation is applied. In the open world semantic, negation used is the classical form of negation, with not A means that A is false. So if A is unknown, then neither A or not A is true. While the closed world semantic used negation as failure, with not A means that A is false or unknown. Basically, not A means A is believed to be false. So that A and not A is always either true or false. As a consequence, when information is added to the knowledge base, some logical entailments needs to be adjusted to take consideration of the new information, because when A was believed to be false now could be found to be true, which is a consequence of the non-monotonic nature of negation. Now, to write rules on top of ontologies is essentially a two-step process. First is you choose your ontology and construct all of your class constructors and axiom in the ontology, and you can use a description logic reasoner to ensure that the model is consistent. Then you could add rules that use negation as failure to make the whole model non-monotonic and to make it consistent with behavior as expected that we have in relational databases, for example. However, care must be taken to avoid adding rules that are class constructor or class axioms. These rules should be put into the ontology so that we could ensure that the ontology remain consistent. So that completes the second segment of the three-part presentation. The next segment will talk about how this can be used as a foundation for a model-driven architecture. Thank you.